Hi, Doctor.
Hi.
Simran, recording can be begun done later, not now.
Yes.
Okay.
Shall we begin, Simran?
So we could wait a couple of minutes, probably 2-3 minutes, and have some more participants join, and we can start.
Yeah, I can see almost 42 have joined.
Yes.
Yeah. So, yeah, good morning, good afternoon, and good evening. Sorry for sounding a little dramatic right in the beginning. Well, there's a reason, because we have participants and panelists from across time zones in this very important webinar titled Decoding Zoonoses, a Global Perspective. Before I hand over the session to my co-host and moderator, Ms. Jennifer Brandt, a couple of points. The first is, I would like to start by paying tributes to two of the leading luminaries whose work in the arena of zoonosis has contributed to saving millions of lives even to this day. The first being the German pathologist, Dr. Rudolf Virchow. He was the first one to talk about zoonosis, who coined the word zoonosis, and who in fact published a full article in his book, The Clinical Handbook of Infectious Diseases, way back in 1855. He's called as the father of zoonosis, which all of us are aware. And exactly about 3 decades later, Professor Louis Pasteur, injected the first vaccine to prevent and protect rabies on this very day of July 6th, which is called the World Zoonosis Day. So on behalf of Innovation Council, Geneva, Emerging Biopharma Manufacturers Network, and Tech Invention, I would like to welcome you all to this very important webinar on this very day of World Zoonosis Day. I would like to now hand over the baton to Ms. Jennifer Brandt from Innovation Council. For most of us, she needs no introduction because she's a leading luminary in the field of policy and advocacy, works very closely with the Geneva Impact Hub, works closely with large organizations like the WIPO, the WHO, part of various manuscripts and editorials which have got published. Of course, I wouldn't want to come in the way of the panelists and you. So over to Ms. Jennifer Brandt to give a brief overview of Innovation Council, introduce the panelists, and let's get going with this webinar. Over to you, Jen.
Thanks very much, Syed. I'm very happy to be here. Happy World Zoonoses Day to everybody. Today, I'm excited to tell you that we have speakers from every region of the world representing a range of perspectives from research to academic, professor, businesswoman. They've been involved in virtually every aspect of researching, developing, commercializing new products. And today they'll be telling us about their activities in relation to zoonoses specifically. So as Syed mentioned, I am the director of the Innovation Council based in Geneva, based here in Europe. We are a group that brings the perspectives of different types of innovators to policymakers in Geneva and other places. So we work quite closely with Syed and as well as other entrepreneurs all over the world to make sure that their voices are part of policymaking, to make really good, especially innovation and tech transfer policies. So without further ado, what I'd like to do is introduce the speakers one at a time. We're going to have the speakers first set the stage, tell us more background about zoonoses, including some work in relation to AMR. And then we'll go to the commercialization and localization topics, looking a little bit more at what it takes to get local manufacturing up and running and to build capacity in that respect. And then finally, we'll look at a case study of a successful product development and research that's currently underway. So our first speaker is Professor Urmi Bajpai. She's coming to us from India today, and she has an incredible bio. She's a researcher, she's a professor, she's an advisor to nonprofits, co-founder of a research institute in the United States. She's a really wide-ranging set of activities. And one interesting part of her work, which she'll be telling us more about, is in relation to AMR, to antibiotics resistance, as it relates to zoonoses. So Professor Bajpai, why don't you get started? Welcome your presentation. Thanks.
Thanks very much for the kind introduction. And I thank Mr. Saeed also for having me. Nice to meet you all. So yes, you're right. I'm working on the MR and I would like to link the two. They are intricately linked anyway. So happy Zoonoses Day to everyone. And if you could have the first slide, please. This is like theme of this year is we can move to the next slide, please, where my start. Simran, can we move to the next slide? So one world, one outlook is the theme of this year. And we have been always, we have started understanding the importance of One Health now, but the microbes and the animals never believed in boundaries. And, you know, that's what is now kind of giving us the situation where we have to address these cases. So the next slide, please. So I'll begin with what zoonosis is, though this able panelist, everybody knows, but in case the participants don't know much about zoonosis and One Health. So zoonoses are infectious diseases which are transmitted to humans using non-human animals as their primary host. And the transmission can occur either directly or by using indirectly through vectors. And zoonotic pathogens can be of any nature, bacteria, virus, parasites, etc. And according to Center of Disease Control US, 75% of emerging infectious diseases in humans come from animals. So that's what is that tells the extent to which we are intricately linked. And One Health is the idea that the health of people is connected to the health of animals and our shared environment. So when we project one, we help everyone. That's the message. And the next, please. So if you see, this is a classification of different zoonoses depending upon who works on which disease. So depending on the experts, whether bacterial diseases or viral or protozoan. I work on bacterial disease called tuberculosis. And so focus is on, for me, it would be bacterial zoonoses, but we have seen that viral zoonoses are more popular in public perception because of several viral zoonoses which emerged in the last 30 years, which I'll show in my next slide. And we'll see, if I take you through from 1990 to 2020, we will see very many viral outbreaks happened. And those happened because of their origin light in animals. The next slide, please. So this will show, you know, we all have heard of these terms called Nipah virus, the SARS virus, Ebola, Zika, and of course the COVID-19. And COVID-19, I think, was a disease which brought public's attention to how important, how viruses can jump from one host to another and how we should space from each other. So these diseases are occurring. And if you see, they have been occurring since last many centuries, but the frequency of occurrence of such diseases have happened, increased because of increased interaction between animals and humans, because of human population and also because of the encroachment and poaching and all those non-healthy practices. So we have to look at how can we now, having come across something like COVID-19 and the antimicrobial resistance being a silent pandemic, though those of us who are working don't consider it as silent, but still public at large is maybe not as familiar as they were panic-stricken in the case of COVID. So we'll see that in the zoonoses in the perspective of antimicrobial resistance, which I'll show in my next slides. So antimicrobial resistance, as if we can move to the next slide, please, is resistance to antimicrobials by microorganisms. Next slide, please. So what is antimicrobial resistance is when the microbes gain resistance to antibiotics or any antimicrobials. And if they gain resistance, then we are not left with solutions to control their population and prevent them from infecting us. So the antimicrobial resistance, AMR, is a very common word to be heard these days in clinical settings. And it's a major threat to global health and human development. And it is also considered as a national security threat, because if the population or the armies or the defense forces, healthcare people, they fall sick of, they get victims of AMR, then we will be in big trouble. And COVID-19, of course, has exacerbated the situation. And so we need to understand how we live in an interwoven world. That is the message of these zoonoses and AMR and One Health concept. Because AMR is not merely a medical problem. It is also an economic and social issue, and it impacts humans, it impacts the animals, animal lives, crops, and economy and the climate. So I will just take one example here, which is of, like you can see in the center, you have high pathogen burden. So you see these pathogens can be carried by the vector, and vector population can in turn, the previous slide only. So the vector can then pass on these pathogens to another host. So this is a connection which I think people are aware of. Then supply of livestock products, for example. So if there is contamination of pathogens in such products, they can reach humans directly. And so this, if you see, in somewhere or the other, we are interconnected. And as we see with the growth of population, there is an intensification of livestock production. And we know that when you have intensification of production of such animals, it will not be, we don't have that much space. So they are like farmhouse factories. They're produced in factories which are crammed, and there are unhygienic conditions. So they are very breeding ground for infections, and those infectious organisms can pass on to humans very easily, to either through the farmers or by the consumers. So we have a very strong cases of direct transmission of pathogens from animals to humans, or to humans. So next, please. And also we have to see that how zoonotic diseases are connected to AMR, because if the pathogens infecting animals, they are resistant to antibiotics, then they can pass on the same bugs to us. And so even if we never had contracted or we did not consume antibiotics, we can acquire a strain which is resistant to antibiotics. So antibiotic usage, excessive antibiotic usage, both in human medicine and in agriculture and in livestock, has led to this rise. And I would say typically we talk about humans misusing the antibiotics being misused in human medicine, but a large chunk of antibiotic excessive usage happens in agriculture and livestock sectors. And globally, over 70% of antimicrobials are used as growth promoters or prophylactics for animals raised for food. So you can see that where these antibiotics are consumed and leading to gross resistance to them and spreading all over. And it was a British economist, Jim O'Neill, who had first demonstrated direct links of antimicrobial resistance in humans with the antibiotic consumption in animals. And this graph is predicting, the gray bars is the situation of tons of uses of antibiotics in 2010, and blue bars are the use of antibiotics in 2030. So you see that in some countries it's going to be rising very steep, whereas some countries where they've banned the use of antibiotics as prophylactic measures in animals, they are able to contain it. So this is a good practice. And what I'm showing here on the right is the famous Gordian knot. So it's typically more so in the LMIC, the lower and middle income countries, where you see, if you see the animals, the tree, the travel part of humans, and the absence of hygienic condition, not all across, but to a large extent. So these all factors contribute to the growing crisis of antimicrobial resistance. And as we say that the world is, it's one world, so it doesn't take too long for transfer of a pathogen from one part of the world to another in a very short time. Next, please. And of course, no talk can be, next, please. And no talk can be over without bringing in the climate crisis. But before that, we have to address this question that, of course, zoonotic diseases have been around, as Mr. Saeed mentioned, that it was a German Dr. Rudolph who had first connected the animals and human diseases. But why do we see a rise? So we have to understand. It is primarily because of the intact contact between humans and animals, which has increased a lot. There's a rapid human expansion because of the population explosion and the urbanization. It is predicted that by 2030 or something, 3/4 of the world will be living in urban cities. So you can imagine the kind of displacements that happen and land use changes. And deforestation also leads to, is also a reason for zoonotic diseases, because animals lose their natural habitat. Climate change, as discussed in the next slide. Globalization is, interconnectedness, which is good, but then it is bad in terms of transmission. And because of the population rise, the food habits are changing, and there's a raised demand for animal protein. And you can see here how they are farmed. And so in this kind of space, these are perfect breeding grounds, not only inhumane, but also perfect breeding ground for various pathogens, which can easily be passed on to humans. And so, and next slide will show that how is climate, because, there's a slide before this, I think. Why is there zoonotic? Okay, never mind. So if, now having said this and having linked the zoonotic diseases with the antimicrobial resistance, we need to find what are the solutions vis-a-vis antimicrobial resistance, because the antibiotic pipelines are drying. There's not much incentive to pharmaceutical companies to come up with new antibiotics because of the limited use. And also, even if you bring in new antibiotics in today's time, the resistance to them can be gained by bacteria in a very short time. So I work on bacteriophages as my research area, and bacteriophage encoded license. So I hope I'll just give a brief introduction to what bacteriophages are. Next slide, please. So that just to introduce you, okay, this is the one. Oh, I think the title has changed. So this slide is actually about the climate crisis. So this shows that, the increased heat wave we all are witnessing around the world, which is called rising temperature. And, one term like permafrost thaw itself can show that if this thaws happen, then all the microbes which are sitting quiet beneath the surface or above the surface, Earth surface, would start working, metabolizing, and release greenhouse gases, and also can, they could be potential pathogens which we are never exposed to. And so these, the increased cases of enteric infections and parasitic diseases, they also are happening because of rise in temperature and other climatic changes. And especially those species with a narrow thermal performance curve, they are more vulnerable to shift in temperature, because the moment temperature changes, their overall survival changes. And so life cycle of pathogens and vectors are influenced a lot by climatic changes, and also by changes in the land use and land cover. And also major vectors for infectious diseases such as mosquitoes, ticks, and fleas, they increase in warmer temperatures, and they cause the transmission at a higher frequency. So they have a very direct role to play in transmitting disease-causing organisms from animal to humans, etc. So you can see the floods, the droughts, the storms, the precipitation, warming, we are all witnessing it, and they are so interconnected with the microbial world we live in. The next slide will show you what bacteriophages are now. I hope it's not abrupt, but antibiotics we all are familiar with. Next slide, please. So antibiotics are like small, they are chemical entities, very well characterized, small in size. Whereas bacteriophages are the natural viruses of bacteria. So if you see here, these shapes like, these are the bacteriophages. And because they're found in nature and they tend to infect bacteria and kill them, can they be used as antibiotics? Now, it's not a new question because this is a 100-year-old therapy. In fact, antibiotics came later. The bacteriophages preceded antibiotics, but then because of the simplicity and effectiveness of antibiotics, bacteriophages were long forgotten. But now with the rise in antibiotic resistance, bacteriophages have gained a lot of attention from all over the world, and especially in the last a decade and a half. So just to simply show that, we know factories. So if this one bacteriophage infects, this oval purple thing is a bacterial cell, and this is the phage, which is the virus. So like the coronavirus infected our cells, here the bacteriophage infects a bacterial cell and then uses the cell as a factory to make its own copies. So this bacteriophage can make its own copies, and then it has to kill the cell to get out of the cell to infect more cells. And in this process, it uses an enzyme which weakens the cell wall and causes the damage, you see. So, antibiotics, many antibiotics work on the cell wall of bacteria. So here we have natural phages and their enzymes, which can also do the same job. And so bacteriophages are the natural viruses of bacteria. They are the most abundant biological entity. And hence, theoretically, we have an inexhaustible supply of phages if we want to develop them as antibacterials. Endolysins are lytic enzymes which act on the bacterial cell wall for the release of phage progeny. And then these phages and lysins can be used for various applications in humans and in animals. In this example, we are showing humans because it is from a review, another review we have authored. But same phages can also be used in animal treatment of bacterial infections in animals. The next, please. So a lot of emphasis on bacteria is happening because they can kill antibiotic resistant bacteria. So if I'm infected with the antibiotic resistant bacteria and I am not responding to any antibiotic, the phages can and the lysins can still kill them. So that is the major advantage. And also biofilms, they tend to contribute to antimicrobial resistance a lot. And the phages and lysins can, inhibit or disrupt the biofilms, and hence they have very strong clinical advantage. And they're very specific in action. Unlike the broad spectrum antibiotics, phages are specific in action, and hence they don't affect the commensals or the symbiotic flora, which is very good. Otherwise, these also lead to another kind of diseases. They're safe for environment because they are natural, so they're biodegradable, and they don't persist in environment so that the bacteria can gain resistance against them, though they do, but not to the extent of antibiotics. Then another advantage is that these bacteriophages and lysins can be used synergistically with other antibacterials. So, they together can make the antibiotics come back. And last is the biocontrol agents. So phages can also be used as biocontrol agents to contain foodborne pathogen. With this, I lead to my last slide, which is what are the solutions? So we have talked about the last slide, please. So what are the solutions when we talk of AMR, zoonoses, and climate? All are very heavy terms, and it can cause panic. But the last slide, please. This slide is showing how a lot of companies and literature is being published on animals. So the solutions, as you all know, these are known things. My emphasis would be on the wash and sanitation and hygiene, which is called WASH, because this is something which does not require too much of R&D. It's common sense, but it requires behavioral changes. And of course, the collaboration and partnerships at national and international levels, because such problems cannot be solved by individuals or even one country or few countries. So with that, I conclude my talk, and I hope it was informative. And my emphasis is on collaboration and partnerships, which can, and leveraging expertise and infrastructure as well. With that, I thank you so much for giving me this opportunity. I spoke very fast, I think, but still it was 10 minutes.
It was very complete. It was excellent. I have a few questions, and I wanted to actually encourage the audience to submit their questions in the Q&A or in the chat, because we will take Q&A at the end after the 3 presentations, and you can engage directly with the panelists in that way. So what I'll do is I'll move to the next presentation. We'll do the presentations all at once. Next up, we have Dr. Nibal Dahaba. She's coming to us from Egypt. She works for Gennecs Pharmaceuticals and Genvax. She has, like Professor Bajpai, an extensive bio. She has really played a leadership role in the private sector, especially in the Middle East and Africa region, especially North Africa. She's been involved with, the launch of Humira in the region, this important biologic from AbbVie. She was behind getting the Egyptian government to prioritize vaccination for hepatitis C, which was a resounding success from a public health perspective. And she's been really at the forefront of a lot of different issues with government affairs, commercialization of new products, and now today with local manufacturing and localization efforts. So she's not feeling so well. She might stay off video, but we'll still get to benefit from her expertise and insights. So over to you, Dr. Dahaba.
Thank you so much. And yes, sorry again for my voice. Yeah, I'm not feeling very well, and I'm not even in town. I'm very happy to be with you today. I'm very happy from the panel. We are 3 women, and even the mediator is a woman as well. So woman empowerment panel. So thank you, Dr. Said, for having all those great women. Let me give you a very brief on what I have been doing. I'm a pharmacist. I graduated from Cairo University. I had my postgraduate from George Washington. And then I started my career. I joined a couple of multinationals, Novartis, MSD. I was involved in their vaccines line. And then I launched AbbVie, which is the biotech arm of Abbott, across 52 countries in the region. AbbVie is a new spin-off from Abbott. And then I was heading Sanofi Pasteur for Egypt and the region, which is the vaccines arm of the French Sanofi. Currently, I'm the co-founder and general manager for Gennecs and Genvax. Let me tell you what's Gennecs and Genvax. Gennecs actually is the pharma arm of a big holding group, which is owned by a family office based in UAE and Egypt. The family office or Dahaba holding have been established maybe 60 years ago. They're working across multiple sectors with multiple governments across our region, in specific in GCC, Egypt and Africa. And then after the COVID, they decided to have a pharma arm. So we did establish Gennecs. So as we speak about zoonotic diseases or those infectious diseases that are transmitted through animals to humans, we have 2 very important, I guess, yeah, we can move the slides. Do you hear me? Can you hear me?
Yes, we can hear you.
Okay. Yeah. Okay. So let's have some examples from across the region and in specific Egypt. I guess you've mentioned the virus C or the HCV case. There's no vaccine for virus C. So I guess you meant the treatment campaign. Egypt was the biggest and the largest evidence and incidence, prevalence and incidence country across the world when it comes to virus C patients. We had millions and millions of patients, and it started with a zoonotic disease, which is the schistosoma, that was spreading through the Nile in the snails that are inside the mud of the Nile. So the first maybe 500,000 patients were infected. And then we used to have this cure, which is tartaric acid. It used to be given as a syringe. So the syringe was a metal one that used to go from one arm to another. And here started the spread of virus C. And yes, I was part of having the American treatment drug with 1% of its price. So we did a massive campaign, which is one of the main success stories for Egypt in the healthcare. And the waiting lists are all cured. And now we are declaring Egypt as free of virus C very soon, in a few months. So yes, virus C, for sure, thank you for mentioning it, was one of the big zoonotic, yeah, it is considered as a massive zoonotic disease. Now they are debating, is it really a zoonotic disease or not? But by then it was considered as one of the top zoonotic diseases. So it is a success story for Egypt and a journey that should be told. So this is when we talk about a local zoonotic disease. When it comes to a regional one in Africa, we have many. We have the Ebola, we have the malaria. The malaria, I believe, is a big zoonotic disease in Africa. Yes, there is no, now you know that everyone is working on a vaccine for malaria. There is no such 100% preventive vaccine for malaria. We do, some of the countries we have seen very good practices in terms of bed nets. Kenya have been using the technology. Rwanda have been using the education and the knowledge and the spread of how to stop the malaria techniques. Yet a vaccine should be in place because I believe malaria is a burden on our continent. So back to how to relate between zoonotic diseases, vaccines, and the importance of vaccination and the local production when it comes to vaccines in the region. As you know, yes, I guess we can move the slides. As you know, Egypt has the best infrastructure when it comes to pharmaceutical localization industry. We have more than 1,000 production lines. Yet, unfortunately, all of them are generics, not biological based or not vaccines or oncology, which are the biological landscape which is needed in Africa. Africa consumes more than 1 billion vaccine doses per year. 99.9% of those 1 billion doses are fully imported, and even the 0.1% is locally packaged only, not even fully localized or produced. So do we need vaccines, localization of vaccines? Yes, we do. We don't need one Genvax, which is the one we're doing. We need 10 or 20 Genvax to cater the African continent when it comes to local vaccines production. I guess we need to move the slide. Yes, one more, please, to the Genvax part. Yes. So the WHO roadmap for Africa is that by 2040, the African continent should be producing 60% of its local demand inside the continent. And they are pushing hard for this. As you know, Dr. Sayed is on top of all the discussions we're having with AVMI, with Gavi, with UNICEF. Everyone is pushing for African manufacturing of vaccines. Yeah, one more, please. Yes, one more. So why did we choose Egypt to have our Genvax facility? First of all, we are targeting to cater the whole African continent, not only Egypt. So we need to start export. To start export, you should have the WHO PQ. And to start the WHO PQ, your regulatory body inside the country should be at ML3 or above, maturity level 3. So Egypt was one of the countries who was certified as ML3. So this is one of the biggest reasons why we choose Egypt to have the facility. Also, Egypt is the first biggest population after Nigeria as a non-Gavi country. So Egypt is the biggest population from the self-procured countries, which is very important because at the end of the day, the country and the local population should be viable enough to have your project on it. And Egypt per year consumes around 90 million doses of vaccines. Where's the location of Genvax? Genvax is located in the Suez Canal industrial zone, which is a new free zone that has access to the Red Sea and the White Sea, and has so many incentives for investors and export. And it's done. That's the 3D. That is done by the Italian company CSV. CSV is one of the top EPC contractors that have been doing the Marseille Étoile Lyon Sanofi's vaccine facility, the new one for Pfizer in Italy. So they are specialized in biological and vaccines facility. They are the one doing our project. One slide, please. So what's our portfolio? Our portfolio is having actually all the vaccines that are there in the NIPs across Africa. So even the new ones that WHO is pushing to be added and to modernize our NIPs. Mainly, we are targeting the killed vaccines. We have a special project for the live vaccines, but it won't be on the same site. As per the WHO, live and killed vaccines cannot be done at the same site. So we're targeting the full portfolio. One more, please. The capacity, as we currently stand, is 115 million doses per year on one shift base. That's for one filling line. Definitely, we can increase the capacity by increasing the shifts or adding more filling lines. And we're targeting the full production cycle, not only fill and finish, but also drug substance and antigen formulation. One more, please. The investment cost of the whole project is $150 million. This includes the R&D center, because back again to where we started, when we are having a customized localization project for Africa, you should be ready for any strains that is emerging from Africa. The same as what happened with HIV, the same as with those customized strains that started in Africa. So we will have a strain bank, we will have an R&D center. So this cost is also including the R&D, not only production of biosimilars or vaccines that we have the tech transfer provided from other suppliers. No, we'll also have our R&D. One more, please. So back to the WHO pre-qualification process, and what's the cost of this from the 150, so that you have an idea on how sophisticated the WHO process is and how it's impossible just to have the facility without alignment with WHO, and then you can go and say, I will have the WHO PQ. This will never happen. So you should be from first step, from the layout step, in full alignment with the WHO, because the cost only for having a facility with the WHO PQ from the $150 million is $60 million. So we could have just saved those $60 million and did a normal state-of-the-art facility, and then say, hey guys, we need to apply for PQ. And that's what now is happening, because everyone now is interested in getting the foreign currency, everyone is interested in export. So we have seen pre-established facilities looking to get the WHO PQ, and this is, let me say, the least I can say that it is quite impossible. So we are in full alignment with those entities. Those entities are the ones responsible for each pillar of the building, including engineering, QC, QA, everything that has to do with the PQ, and tons of files, tons of people, inspection teams coming and going. Even in this stage, we are in the stage of having the basic and details drawings. We had the layout approved, as you will see in the milestones, already from the EDA as the first vaccine full production cycle facility in Egypt in the history of EDA. And now we are submitting the basic and details. One more. So that's the different prices per product. As you know, the PQ is per product. So yes, the facility should be in full alignment so that your filling lines as per each product should have the PQ. but the PQ is given per each product after the commercial batch and all of this. So those are how the WHO rates each and every vaccine. They see that some of the vaccines are the priority list now, even though some of them are not included in our NIPs. And that's why we work closely with WHO to also modernize the NIP, the local NIP. We work closely with MOH, we do the lobbying, and we did this with the IPV. We were the ones who introduced the injectable polio vaccine to the Egyptian NIP. They only used the oral one, the BOPV, and we were the ones who succeeded after 4 or 5 years maybe of lobbying to introduce the IPV as a first dose and then as 3 doses. So working with the government and all of this and on the medical side is part of our job as well. So local vaccines production is not only a facility thing. No, it's a full cycle medical process. One more, please. So yes, I have mentioned already the layout approval, which was a historical cornerstone for us and for the EDA. And it was right after they were certified as ML3. One more, please. Yes, 2 or 3 weeks back, we signed the Genvax Academy. As I said, since Genvax is a full process, not only a production facility, so having calibers that are quite experts in the vaccines production are something that we lack in our region. So, for example, as you will see in the team chart, I had to headhunt all my Sanofi people from all across the world, by the way. Of course, I work very closely with Dr. Said and his team. They are the global experts. Yet we don't have local calibers. And I don't want to run Genvax by foreigners. And I don't want, after 20 years, to still run it by foreigners. So we need to have the base. So we did launch the Genvax Academy, which is an academy to take people, Egyptian young people, whether from the government, whether for our team, or whether from the students, undergraduate, from the medical schools, and give them certifications from all global entities. And this is done in under the patronage of His Excellency, the President Sisi, and it was done during the Africa ExCon, and we co-signed with UPA, which is the Unified Procurement Body of all the medical related stuff in Egypt. So this was another very big milestone for Genvax. As you can see, Genvax is already very well recognized locally and globally. When you are talking about a vaccine facility, everyone was talking about having a vaccine facility during the COVID, but very, very, very few ones are the real projects that really sustained their presence. And thanks God, Genvax was one of them. One more. So also, as we're doing a new localization era, it should be very well aligned with the UNICEF's SDGs, especially the clean energy and the zero carbon goal. Egypt has hosted the climate conference, the COP, last year, and we were quite presented there. And we will be having the first solar panels for vaccine facility. And last but not least, that's the team behind Genvax. We have gathered and handpicked all the global experts, including the head of the former head of Vaxera, Dr. Nibal, and all those people who were running. Richard, the project lead, was the one heading BioVac in South Africa. We have Steve and his team were the ones heading Marseille Étoile, the Lyon vaccine facility of Sanofi. So we have done our best to get the best team when it comes to vaccines production. And I guess we're all working hand in hand to have this dream coming true. I'm open for questions after your presentations. And thank you so much for having me.
Thank you so much, Dr. Dahaba. That was a really interesting overview of what you're up to, this whole localization project. And I really found it interesting how you were talking about the talent, that fine line to walk between securing the right international talent and making sure that you have local talent also staffing your facility, and engaged with your R&D programs and manufacturing. That was really interesting.
Thank you.
Yeah, so we're gathering questions in the Q&A. Keep submitting your questions. If we don't get to them, we will put them to the speakers and try to answer them afterwards. But I'd like to give the chance to Dr. Colonna of Inmunova. She's with us from Argentina today. She is a researcher. She's been engaged in projects for contract research organizations, in addition to big multinational companies, mostly managing clinical trials all the way from phase 1 to phase 4. And she's going to give us a case study of the development of a treatment for hemolytic uremic syndrome, which she'll tell you more about. Over to you.
Thank you, Jennifer. Thank you for the invitation. Well, as Jennifer mentioned, I'm currently the head of clinical research and regulatory affairs in Inmunova. It's an Argentina biotechnology company dedicated to research and development and the treatment of orphan disease. So I'm a biochemist as a background, and I will show you what we have done, what we're doing in Inmunova, and how we are targeting one of a specific zoonosis disease. So as I think has already been said, what is the situation on zoonosis in Latin America? As we all know, this is a global public health security that has been threatened by zoonotic disease emergency, like outbreaks of influenza, chikungunya, and SARS-CoV-2. And this emerging zoonosis may be driven by a modernization of farming practices, habitat destruction, and human encroachment, and climate. So this applies all over the world, and in Latin America, 70% of the public health emergency reported to the WHO are classified as zoonosis. So many of these neglected diseases that affect mainly poor and marginalized populations. So this is a very critical area. So the next one. What is the situation in Latin America? We have re-emerging zoonotic diseases as tuberculosis, listeriosis. Hemolytic uremic syndrome is the topic of my presentation. There are other emerging zoonotic diseases still, like Ebola, influenza, and unattended zoonotic diseases that are endemic, like toxoplasmosis, Chagas disease, brucellosis, giardiasis. So there's many work to be done. So in particular, I'm going to give you some background of HUS. The next one, please. The next one. So if you're not familiar with HUS, this is an orphan disease, and it's caused by a bacteria that's called Escherichia coli that produces a toxin that is called Shiga toxin. STEC are one of the major foodborne pathogens worldwide, and it has been described that it could be over 3 million acute illnesses annually and over 50,000 of cases of bloody diarrhea per year. What happens? 10 or 15% of these cases will develop this disease that's called hemolytic uremic syndrome, a life-threatening disease. It can occur in patients of all age, but mainly it occurs in children between 1 to 5 years of age, and also in patients with weakened immune system. 40% of these patients with this disease will develop longer-term sequela, very critically sequela, something that could be mild, like hypertension, that will require treatment per life, until chronic kidney disease, and ultimately transplant of the kidney. In the United States, HUS is the principal cause of acute kidney failure in children. As I mentioned, this is an orphan disease. That means there's no specific treatment worldwide for this disease, but supportive care, mainly treated by dialysis. The next one. So this disease, majority occurs as an outbreak in the rest of the world. And here there are some cases that are mentioned in Japan, Scotland, Canada, US, Germany. You may recall 2011, there was a very huge outbreak in Germany that affect adults. And but these are outbreaks. You don't know when they're going to happen. And as I mentioned, this is a foodborne disease, and any food contaminated can be the factor for causing this disease. In Argentina, the situation is different. This is an endemic disease. That's why it's so important, and we are looking for a solution. And we have almost 500 cases per year. Could be a little bit less in the last year, and 15 deaths annually. The next one. So just to let you see a big picture of how the disease evolves during time. So at first you have an ingestion of steg that is through contaminated food or water. And you may have symptoms like a gastroenteritis, right? Diarrhea, bloody diarrhea, vomiting. And 10 to 15% of the patient will develop this disease that is characterized by a triad that you have patients with renal failure, with thrombocytopenia, and with hemolytic anemia. And clinically, these patients had anuria, they have hypertension, they are with pallor, and well, mainly the anuria is the main factor that will require that these patients go to dialysis because they cannot eliminate the toxics from their body. So almost 60% of the patient will require this treatment that is not innocuous. 80% will require transfusion because of this anemia. They have to replace their blood cells. And up to 20% can have neurological complications that can go from a seizure to patient being in coma. They will have other complications as a pancreatitis, necrosis of the intestine. They can have an infarct, so very severe acute manifestation. And death has decreased during the last year, so it's between 1 to 3% of the patient will die due to this disease, mainly due to neurological complications. What happens if we see a picture in a 5-year follow-up? 70% of the patient will fully recover, but what happens to the other 30 that will have this renal sequela? Think that we're patients between 1 to 5 years that will remain alive with these complications. Either they will have to keep in dialysis or hypertension, and some of them, up to 2%, could require a transplant in their adolescent life or adult life. Less than 5% will develop a neurological sequela. So as you can see, the morbidity of the disease is very high. The next one, please. So in this sense, Inmunova has been working on developing a drug to treat this disease. And the target for this disease, as I mentioned, is the Shiga toxin. That's the one that is generating the cytotoxic damage at the cell. So once you ingest the bacteria, the toxin is released in the intestine and then to the bloodstream, and is the one that will attach to the cells through the G3B receptor that are mainly in the kidney cells, but as well as in brain and in heart and on all other organs in the body. And through the internalization will cause cytotoxic effects. So it has been proven in animal models that if you neutralize and you inhibit the action of the toxin, you can prevent that in animals, you prevent death. So all companies that have been targeting some treatment for this disease the target has been to neutralize the Shiga toxin. So our challenge is to generate good immunogens so we can generate antibodies with high affinity to neutralize this Shiga toxin, and then stop the progression of the disease. The next one. So Inmunova has developed a chimera that's called BLS, that comes from a protein called Brucella lumacin synthetase. And it's a patent that is protected worldwide. And what we have done using this protein is attached at the surface, at the extremes, the Shiga toxin, both 1 and 2, that are the main Shiga toxin from this bacteria. And in this way, we form this chimera that is the immunogen that's very potent and very stable, and you can then generate different platforms, since vaccine and to antibody, because the immunogen will expose to the immune system the Shiga toxin and will generate antibodies. So in particularly for our proposal to get a product in human research, what we have done is generate a serum, a horse serum antibody. If you can show the next one. So the process to generate these antibodies is you inoculate horses with your immunogen, in this case, our chimera with the Shiga toxin attached. The horse will generate antibodies with very, very high affinities for this Shiga toxin, and then you extract the serum, you cleavage the immunoglobulin, and you get a product that's anti-Shiga toxin, and in our case, neutralize the 8 variants that exist of Shiga toxin. This is a manufacturing process that is well known for antivenoms. And it's safe, and it can be improved through many trials. And of course, we are in the phase of proving safety for our drug. We have done a phase 1 clinical trial that's done in healthy adult volunteers with excellent results that were done in 2018. And during this last year, we have obtained what's called the orphan drug designation by a European agency as well as the FDA, and also given the rare pediatric disease designation. So what we have done is design a clinical trial to prove safety and efficacy of our drug for these patients. So the next one. And this clinical trial is a phase 2 trial where we are looking for safety and efficacy. And what we want to see in patients with stage A2S, meaning that we are already with the patient that have the disease, and to look improving renal involvement. That means if we can prevent the patient to go to dialysis or reduce the days of dialysis. This is the major surrogate for chronic disease. The more the patient has a renal failure, the more probability or worse prognosis to develop chronic kidney disease. We will assess, of course, safety of the drug and also pharmacokinetic. That's what we do in a phase 2 trial. And as secondary endpoints, we will see if we can reduce mortality, reduce hospitalization days. That, of course, is associated to morbidity and to health costs. Prevent and reduce short-term renal complications. As I mentioned, it could be hypertension and other complications that are extra-renal, like neurological or gastrointestinal or cardiovascular. So we are doing a clinical trial in acute phase of the disease to see if we can reduce the acute manifestation that will then make an impact in the chronic manifestations. The next one. So in terms of implementation of the therapeutic intervention and the time window, the drug is administered once the patient is admitted to the hospital and the diagnosis of A2S is done. The patient is offered an informed consent. If they accept, they're given the drug, and then 24 hours later, they are given a second dose. And we follow the patient for 28 days to see if they have any of the manifestations mentioned before as endpoint for the trial. The next one. So where are we now? We have concluded this study 1 month ago, and this study design was an open label study with a controlled historical arm, where we enrolled 125 patients in the control group, and 57 patients were treated with our drug since October last year until May this year. We have no safety concerns with the drug, and we're currently doing data analysis, very promising results. And this data will allow us to continue to a phase 3 trial, and we plan to make the final, what's called the database lock of the study by the end of of this month. The next one. So, as I mentioned, H2S is a seasonal disease. 90% of the cases occurs during summer. We have a low incidence but constant. So being endemic in Argentina makes an advantage to be able to plan a clinical trial, because if we want to do it in a setting where the disease comes as outbreak, it will be logistically very challenging to know where to look for the patients. It's an unmet medical need, and during the last year, standard of care has not changed. There has not been new medication, nothing to do with these patients. The sequela are potentially very serious, and our objective of this phase 2 was to do it in a very short time. We do it in only one summer, to then be able to move to a confirmatory phase 3 trial to prove efficacy and safety. The next one. So Inmunova, what we believe, and we are doing a great job in developing the monoclonal antibodies that have the potential to become the first treatment in the world to treat the disease. Also, during pandemic, we have developed with a similar platform, a SARS-CoV-2 hyperserum, and this was approved. We received emergency approval in Argentina. We have treated more than 25,000 patients with COVID. We are also working in antiserum for hantavirus and other therapies, and we believe innovative treatments are needed for treatment of zoonosis, and we're happy that Inmunova is part of this initiative. The next one, this is our team in Argentina. Thanks to all.
Thank you so much for that. We're out of time, but we promised to answer your questions, and we fully intend to do that. So we've taken note of the questions, and we also have a dedicated email address to answer further questions that you might have. If you send them to this email, we will have those answered. It's connect@techinvention.biz. What I would like to do really quickly is, in the last 4 minutes, maybe put some of these questions that we've already gotten. Most of these are for Professor Bajpai, now that I look at them. Why don't we do this? We'll collect these questions and we'll post the answers on the Innovation Council website and also on Tech Invention, but we'll give each speaker 1.5 minutes for their closing thoughts. Like, what is the one thing that you would really like to leave the audience with today? Your crucial message about what's needed, for example, from them or for policymakers to improve the management and treatment of zoonoses and the access to new products for this. So let's start with Professor Bajpai.
Thanks. So I think we need transdisciplinary approach. That's my major message, because as you see that how the climatic changes that are happening are causing diseases, and then you need antibiotics and vaccines, and then you need awareness. So transdisciplinary approach and finding alternatives understanding that we are running out of time, and creating awareness with One Health. I mean, there's a lot of awareness vis-a-vis the sanitation and wash your hands well, etc. But then to bring in and under the ambit of One Health would also improvise and tell people that how animals, whether they're pets or they're domestic animals, can be carriers or source of infections, which maybe everybody doesn't know. So the way we know about the vaccine plan, every country has their national programs. The people should be made aware about such vaccination program for the pets and the animals, and how, the veterinary doctors, the primary healthcare center, they should work in some unison. So we understand the major chunk of antibiotic resistance and infections come from animal world, but I don't think the two exist together mentally in the people. So we need some behavioral changes and the policy changes to bring the One Health more in focus.
And certainly some awareness raising as well. Dr. Dahaba, what is your one key message to leave the audience with today?
Well, mine would be more of pushing the African continent to get together, to get all the decision-making governments and entities just to start on the R&D part when it comes to something like pharmaceutical and biological and all of this. No one, I have been on the other side for the past 20 years, so let me say it very frank, no one outside Africa would come and help us. We as Africans should start it ourselves, should start heavily on the R&D, because actually we don't have any R&D. So we should have our own centers, our own technologies, so that when a pandemic is there, we are ready for it. So that would be my one message.
Okay, great. Really an emphasis on building R&D capacity in addition to manufacturing capacity on the continent. Excellent. Yes. Okay, last but not least, go ahead, Dr. Colonna.
I think I agree with the last comment, and I think innovation and research is crucial for growing and to in any matter of your life and work, but in particularly treating disease, we need to continue looking, we need to continue investigating, looking for the way to treat disease that are devastating, and of course we need finance support to move forward. So we need to alert and as well as to work in prevention. Of course, that's always the best solution. What we say here is now we have the problem, what we do, but of course, always prevention is the best way to not having the disease, but that's something very difficult to eradicate. So we need to work on solutions all together. It's not only one person that's going to make the difference. It's a multidisciplinary activity that requires money, time, and qualified persons to do the work.
Thank you. So with that, thank you very much. Fascinating discussion and insights. And Syed, I'd like to turn it over to you to close the session.
Yeah, thanks, Jen. I'm really feeling like the odd one out or the odd man out. We've had an esteemed team of women panelists by a vibrant co-host, and also the backend team at Tech Invention, which has put this together, has been two young women, Sonali and Simran. They've done an awesome job. I don't think we could have asked for better or more diverse insights, from polyclonal antibodies, what Dr. Colonna talked about, to vaccines, which Dr. Nibal, and moving on to bacteriophages and lysines, which Dr. Urmi talked about. There have been quite a few questions that are coming up. Our team has taken note of all of them. And also the panelists have put up their email IDs. So either you could reach out directly to them or through to the Innovation Council email ID, which Jen has just put up, or to the connect@techinvention.biz. We will assimilate all these and we will put it across to you, and we promise to get back to you with appropriate answers. This is not just a one-off kind of a session. We would request Gen Innovation Council and the panelists so that we come together on many more such subsequent events, so that we will be able to do some collective thinking, brainstorming, and put up a very resilient, sustainable program across continents that all of us have come together. Thank you once again, and thanks one and all. Have a nice rest of the evening, rest of the day, depending on the different time zones. Thanks a lot.
Thank you.